Hello, thank you for your interest in this ymfc-mini-drone project. It's really a pleasure to show you my recent work. I hope by doing so, more people will be able to build their own flight controller. First, I want to show you a bit history of Jobworking's original project and why it's so good for beginners to learn. Job has designed YMFC 3D and AR in early days. They are built upon Arduino Uno. He removed ymfc 3D on his webpage. There is only ymfc AR left now. ymfc 3D is really easy to develop and only takes around 300 lines of code. I was surprised that a flight controller could be realized in such a little size of code. ymfc AR added auto-level function. Its code size increases to 500 lines. I followed his instructions and built my own flight controller. When my DIY drone is up and running, I am so satisfied. Later on, Job has designed ymfc-32. Its MCU is changed to STM32, but its code is still based on previous ymfc projects, and the IDE is still Arduino. By upgrading the MCU, more functionalities are added, such as attitude hold, GPS hold, and the data can even be transmitted through telemetry system. However, it becomes difficult to replicate his design. I took 2 attempts to realize ymfc-32, the version without GPS. One of them is fried because I accidentally touched the 12-volt power line to one of the 3.3-volt header. And for the most complete version, the ymfc-32 with GPS, it took me 2 months. I think this is keeping the project farther away from beginners, so I have designed my own PCB board for the project. The code and the functionalities are the same, but the soldering work is much simplified. However, when I was trying to bring it to high school students, there are still difficulties. I am worrying that brushless motors are too powerful to experiment with, and in order to implement functions as GPS hold, the size of code has increased. To overcome these issues, I designed this mini drone board. Apparently, by reducing its weight, it's much safer than before. I chipped away the code for advanced functions, leaving only the basic part. Let's compare Job's schematic and mine. Basically, I removed MS5611, the barometer, GPS plus HMC5883L, and APC220. They are all gone. What I kept are PPM receiver, the A0 port, and NPU 6050, and B10 and B11 port. Besides that, I have used the same port for motor output from B6 to B9, same battery measurement port A4, and LED output ports B3 and B4. The serial port for firmware download and the serial print are the same, A9 and A10. As you can see, my schematic looks more detailed than Job's because I am directly using microchips instead of breakout board, so I need to manually add some components to make chips work, but they are essentially the same. One more thing, to drive brushed motors, the energy from PWM output isn't enough. We need MOSFETs. and the PWM signal that is originally controlling ESC needs adjustments for MOSFET. Next week, you will see the modifications in software. What I did is corresponding to the modification in hardware I just talked about. That is removing components and changing PWM outputs. Thank you for watching.